everyone, I'm Mary Swarnalatha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the mean value and the mean square value of system response. So already we have seen the definition of LTA system. So what is an LTA system? Nothing but linear time invariant system. A system is said to be linear time invariant system if it satisfies both the linearity property as well as the time invariant property. Now, how can you say that a system is a linear system? A system is said to be linear if it is satisfying both homogeneity and superposition principle, or else one more definition for linear system is if the response of weighted sum of inputs is equal to the sum of its weighted responses, then the system is said to be linear system. Now, what is time invariant system? A system is said to be time invariant if the input-output characteristics of the system does not change with time. Then it is called as what? Time invariant system. Now, what is LTA system? So, LTA system is nothing but that it has to satisfy both the linearity property as well as the time invariant property. Then the system is said to be LTA system. Now, for example, this is a LTA system and the input applied to the system is x of t and the response or the output of the system is y of t. Then for the LTA system, the output of the system can be written as y of t is equals to x of t is nothing but what? It is applied input convolution h of t. So what is h of t? So h of t is called as what? Impulse response of the system. H of t is called as what? The impulse response of the system. Now what is mean by impulse response? If the input to the system is impulse input, then the response of the system is called as what? Impulse response. Now, what is the definition of the impulse response? If the input to the system is impulse input, then the response or the output of the system is called as what? Impulse response. So, for the LTA system, I can write down the response or the output as y of t is equals to the applied input signal x of t convolution h of t. Now, what is the formula for the convolution in case of continuous time signal? X of t convolution h of t, or else the convolution is satisfying the commutative law. It means x of t convolution h of t is equals to what? H of t convolution x of t. Now, what is the formula for x of t convolution h of t? Integration minus infinity to infinity x of lambda into h of t minus lambda d lambda. And similarly, what is h of t convolution x of t? That is nothing but integration minus infinity infinity h of lambda into x of t minus lambda d lambda. So therefore, this is nothing but the response of the LTA system. The response of the LTA system can be written as the convolution of the applied input signal as well as the impulse response of the system h of t. Therefore, what is y of t equals to x of t convolution h of t. Now, the same concept will apply to the random process also. Now, if the system we are taking as LTA system and applying the random input, nothing but what? The random process. In the previous case, x of t is any input. It may be random or whatever it may be. So, x of t is any well-known signal. But for the LTA system, now I am applying the random input. So, what is random input? Nothing but here random process. Solving by random process whose characteristics cannot be determined, predetermined, nothing but what? Random. Therefore, x of t is a random process. And I am applying the random process to the LTA system. Then, what is the response of the system? It is also again what? Random process only. If I apply a random process as input to the LTA system, then the response of the system or the output of the LTA system is also again a random process only. Then what is y of t is equals to x of t convolution h of t, or else it is also called as, since it is starting the commutative law, it can be written as h of t convolution x of t. That equals to, what is the formula for convolution? What we have seen, integration minus into infinity x of lambda into h of t minus lambda d lambda, or else you can write it as, it is satisfying the commutative law. Then x of t convolution h of t is equals to what? H of t convolution x of t. Then what is the formula for h of t convolution x of t is h of lambda into x of t minus lambda d lambda. So these two formulas are same only, you'll get the same value only. Therefore, for the LTA system, if you apply the random process x of t as the input, then the response of the LTA system is also again a random process that we are represented by y of t. Then what is y of t is equals to the input random process x of t convolution h of t, where the h of t is called as what? The impulse response of the system. Now, so we'll calculate the mean value, the statistical properties of the response of the system. So what do you mean by statistical properties? So statistical properties nothing but what? You have to calculate the expectation of it. So for example, mean value, mean square, and similarly autocorrelation, cross correlation, autocovariance, cross covariance, etc. variance. So all these called as what? The statistical properties. Now, like we have calculated the statistical properties of a random process x of t, in the similar manner we will calculate the statistical properties of the response of the LTA system also. So first we will calculate the mean value of the response of the LTA system. What is the response of the LTA system? So y of t is called as what? The response of the LTI system. So y of t is called as what? The response of the LTA system. Now we have to calculate what? The mean value of response of the system. So what is the mean value of a random process? E of y of t. Equals to, what is y of t? This is the response of the LTA system. How can you write down the response of the LTA system as? The input signal convolution is impulse response. There is nothing but x of t convolution h of t. So that equals to the mean of the response of the system or the output process is nothing but x of t convolution h of t, or else I can write down this as h of t convolution x of t also. That equals to expectation of, what is the formula for h of t convolution x of t as? Integration minus infinity infinity h of lambda into x of t minus lambda d lambda. That equals to, so in this expectation, I have to calculate the expectation of this value function. So the expectation always will calculate with respect to the random process. In this, h of t is impulse response and x of t is a random process. Therefore, you can bring this to the outside. Then you can write down this as integration minus infinity h of lambda. So this is a random process. That's why I'm writing here expectation of x of t minus lambda d lambda. Now, for example, consider the random process x of t is a wide sense stationary random process. So for wide sense stationary random process, what are the conditions to be satisfied? The mean of the random process should be constant for any value of t. The mean of the random process should be constant. And the second condition is the autocorrelation function should be a function of only the time difference. There is nothing but, those are the two conditions for a wide sense stationary random process. So what is the first condition? The mean of the random process is constant for all values of t. Here t may be anything, but That's mean is constant. That is the first condition. And second condition for voids and stationary random process is the autocorrelation function should be a function of only the time difference. What is the time difference here? T plus tau minus t, nothing but what? Tau. So these are the two conditions for to be satisfied for voids and stationary random process. Now we are considering that here the random process x of t is a voids and stationary. Then what is u of x of t is x bar for all values of t. In place of t, here I am having t minus lambda. So whatever the value of t, but the mean is constant. So write down this as integration minus infinity h of lambda into x bar. What is the mean of the random process? It is constant. Let us denote it by x bar. So x bar into d lambda. So since it is constant, you can bring it outside. So x bar into integration minus infinity h of lambda into d lambda. Therefore, this is a formula for the mean value of the response of the system. Therefore, this is a formula for what? The mean value of the response of the LTA system. This is also called as what? Mean. So, mean of what? The response of the system. What is the mean of the response of the LTA system? Is nothing but what? X bar. So, here x bar is a mean of the random process, the input process x of t. It is constant here. So, x bar into integration minus infinity h of lambda d lambda. In the similar manner, we will calculate the mean square value of the response of the LTA system. What is mean square? Mean is nothing but expectation. Mean square is nothing but you have to square and then you have to take the average or mean value. Therefore, what is the mean square? Nothing but E of. And mean square value of which one you have to calculate? The output process or the system response. What is output process or the system response? Nothing but y of t. So, square the mean square of the response of the system. That is nothing but what? E of y square of t. Now, what is the response of the LTA system? Nothing but x of t convolution h of t. And then you are having square. So, write down here whole square. Or else, this you can write it as E of h of t convolution x of t whole square also. Then equals to expectation of. So, what is the formula for h of t convolution x of t? That is nothing but what? Integration minus infinity h of lambda into x of t minus lambda d lambda. After that, what you have here? You are having the square. So, write down here this as square. Then that equals to expectation of. You can write this as, you can write a square as a into a. Similarly, here also integration minus infinity h of lambda x of t minus lambda d lambda into integration minus infinity h of lambda x of t minus lambda d lambda. Now replace here lambda by lambda 1 in the first integral and lambda by lambda 2 in the second integral. Then you can write this as expectation of integration minus infinity h of lambda 1 x of t minus lambda 1 d lambda 1 into what you have here? Integration minus infinity lambda by lambda 2 here. Then h of lambda 2 x of t minus lambda 2 t lambda 2. Now, I have to calculate what the expectation or the mean. So, always expectation will calculate only with respect to the random process or random variable. So, in this h of lambda 1 and x of t minus lambda 1, which is a random process? X of t minus lambda 1 is a random process and it is impulse response. Therefore, this is constant. I can bring it outside. And similarly, in the second integral, which is a random process, x of t minus lambda 2 is a random process. So, I have to calculate the expectation for what? The random process only. So, remaining terms you can bring it outside. Then you can write out this equation as integration minus infinity infinity, and similarly lambda 2 is also from minus 7 to infinity, h of lambda 1 into h of lambda 2 into what you have here, expectation of x of t minus lambda 1 into x of t minus lambda 2. Next what you have here, d lambda 1 and d lambda 2. So expectation of x of t minus lambda 1 into x of t minus lambda 2 into d lambda 1 into d lambda 2. Now, what is expectation of x of t minus lambda 1 into x of t minus lambda 2? What do you call it as? So, we know that the autocorrelation function. So, what is autocorrelation function of a random process? X of t is nothing but what? Expectation of x of t into x of t plus tau. Now, in place of t, I am having t minus lambda 1. In place of t plus tau, I am having here t minus lambda 2. Then, I can rewrite in this equation as what? Rx of, in place of t, what I am having here? T minus lambda 1, comma, in place of t plus tau, what I am having here? T minus lambda 2. So, t minus lambda 2 is equals to what? Expectation of x of t minus lambda 1 into x of t minus lambda 2 you have it. Now, in case of x of t is wide sense stationary random process, then what can I write on the condition here? The autocorrelation function is a function of only tau. Then what is u of x of t into x of t plus tau? Nothing but what? Rx of tau only. So, therefore, what is Rx of t comma t plus tau in case of a wide sense stationary random process? So, Rx of t comma t plus tau is equals to what? Rx of tau only. And similarly, so here in place of t, we are having t minus lambda 1. In place of t plus tau, we are having t minus lambda 2. Then what can I write here? Rx of t minus lambda 1, t minus lambda 2 is equals to Rx of here t plus tau minus t, nothing but what? Tau. And similarly here, t minus lambda 2 minus of t minus lambda 1. So, what can you obtain here? Lambda 1 minus lambda 2. Here also, lambda 1 minus lambda 2. Therefore, you substitute here. Then, what is the mean square of the response to the LDA system is nothing but what? Integration minus infinity infinity, integration minus infinity infinity, h of lambda 1, h of lambda 2 into what is u of x of t minus lambda 1, x of t minus lambda 2 is nothing but the autocorrelation function Rx of t minus lambda 1 comma t minus lambda 2. If it is a wide sense stationary random process, then it is a function of only the time difference. Therefore, how can I write down this as Rx of lambda 1 minus lambda 2 into what you have here, d lambda 1, d lambda 2. So, therefore, what is the mean square value of the response to the system is equals to what? Integration minus 7 to infinity, integration minus 7 to infinity, Rx of lambda 1 minus lambda 2 into h of lambda 1, h of lambda 2 into d lambda 1, d lambda 2. Therefore, this is what? The mean square of the response of LTI system. So, therefore, we have calculated what? The mean value of the response system as well as we have calculated the mean square value of the response of the system, and we are assuming one condition that the input process, random process operating system is a wide sense stationary random process. So, let us see some examples on this. So, a stationary random process x of t is applied to the input of a system. So, a stationary random process x of t nothing but is a wide sense stationary. So what is the difference between Whitesnake stationary and the stationary random process? Whitesnake stationary means if it satisfies only two statistical properties like the mean and autocorrelation, then it is called as what? Whitesnake stationary. Then what is the stationary random process? It has to satisfy all the statistical properties, should not vary with respect to time. Then you can say that a random process is a stationary random process. So what they are given there? The input applied to the system is a stationary random process. It means the mean is constant as well as its autocorrelation function is a function of only the time difference. So for which h of t, what is h of t is called as here? The impulse response to the system. What they are given it as? T square into e power minus 80 u of t. Next after that they are given the mean of the random process x of t is equals to 5. Then what is the mean value of system's response y of t? So what is the mean value of the response of the system? Nothing but what? E of y of t is equals to what? E of h of t convolution x of t, or else you can write this as E of x of t convolution h of t. So already we have derived this equation. So what is the equation we got? The mean value of the response of the system, we got it as what? X bar into integration minus into infinity h of lambda d lambda. Now we substitute this formula here. Then you can write as what? X bar into integration minus infinity h of lambda into d lambda. Now given what is x bar is nothing but the mean of the random process. So what is the mean of the random process? We got as what? 5. It is a constant value, nothing but what? 5. Then you can write down as E of y of t is equals to 5. Substitute the mean of the random process as 5 here. Then integration minus infinity h of lambda d lambda. Now given what is h of t, the impulse response system, they are given as what? T square e power minus 80 u of t. So t square e power minus 80 into u of t. Now what you have to write down here? H of lambda. Then what is h of lambda? How do you obtain h of lambda? You just replace the variable t by lambda here. Then you can write as what? Lambda square into e power minus 8 lambda into u of lambda. Now you substitute the equation. Then the mean value of the response of the system as 5 integration minus infinity h of lambda. What is h of lambda here? So lambda square e power minus 8 lambda u of lambda. So lambda square e power minus 8 lambda. So e power minus 8 lambda into u of lambda d lambda. Now what is u of lambda, which is called as what? Unit step function. How it is defined, the unit step function? U of t equals to what? 1 for t greater than equals to 0 and 0 for t less than 0. And similarly, you can define u of lambda, the unit step function, as u of lambda equals to 1. It is unit step. Therefore, the amplitude here it is unity. So u of 1 when lambda is greater than or equals to 0 and 0 when lambda less than 0. So what do we mean by lambda is greater than or equals to 0? It's nothing but what? The lambda value is from 0 to infinity. So greater than or equals to 0 means the minimum value is 0 and the maximum value is what? Here infinity. Therefore, you can write down as, so from minus infinity 0, what is u of lambda value? 0. So 0 into something you are going to obtain 0 only. Then when lambda equals to infinity, what is u of lambda here? 1. So 1 into when lambda is 0 to infinity. So what is u of lambda value? 1. So lambda square e power minus 8 lambda into d lambda. For lambda less than 0, that is nothing but when lambda is minus infinity 0, it is 0. So 0 into something you are going to obtain 0. That's why I replace the minus infinity by your 0. Then it equals to 5 into, this is like the integration of uv. So what is the integration of uv formula? U into integration of v minus integration of u dash into integration of v. So you apply the integration of uv formula and then simplify this. Then what can you obtain here? Lambda square into, you have to select the value of u such that it should be differentiable. So integration of v, nothing but what is the integration of e power minus 8 lambda? So integration of e power minus 8 lambda is what? With respect to lambda. So e power minus 8 lambda by minus 8. Therefore, e power minus 8 lambda by minus 8 minus integration of u dash. So what is the differentiation of u is? Differentiation of lambda square with respect to lambda is what? 2 lambda. So 2 lambda into integration of u. What is integration of u got? E power minus 8 lambda by minus 8. And what are the limits? Here 0 to infinity. So 0 to infinity. So that is equals to 5 into, if you substitute the upper limit here, what do you get here? Infinity square into e power minus 8 into infinity, nothing but e power minus infinity. What is e power minus infinity? 0. Therefore, the upper limit here is 0. What about the lower limit? Substitute the value of lambda is 0. So, 0 square into e power 0 by minus 8. 0 into something you are going to obtain 0. Therefore, this term will be get vanished. Then what you are getting here? So, this minus will get cancelled. And here, you can write on this equation as 1 by 4 integration of lambda into e power minus 8 lambda by e power minus 8 lambda. So, I brought this 4 to the outside. Then into d lambda and what the limits here? 0 to infinity. So, that equals to 5 by 4. So, this is again integration of v formula. So, u into integration of v. So, what is integration of v? E power minus 8 lambda by minus 8 minus integration of u dash. So, what is u dash here? Differentiation of lambda with respect to lambda is 1. So, 1 into integration of v. What is integration of v here? E power minus 8 lambda by minus 8. And what are the limits here? 0 to infinity. That equals to 5 by 4. Now, if I substitute the upper limit, then what I'm going to obtain here? In place of lambda, I have to substitute because integration with respect to lambda only. So, then what can you obtain here? Infinity into e power minus infinity. So, e power minus infinity is 0. So, 0 into something you are going to obtain 0. If you substitute the lower limit value in place of lambda, 0 into something you are going to get 0. Therefore, the first time you get vanished. Then what are here? So, minus of minus is plus. So, 1 by 8. And integration of e power minus 8 lambda is e power minus 8 lambda by minus 8. And the limits are 0 to infinity. Now, you substitute the upper and lower limits. Then what can you obtain here? So, 5 by minus 64 into e power minus infinity is 0 and e power 0 is 1. So, 5 by 64 into what you have here? 4. It equals to what? 5 by 64 into 4 is 256. Therefore, what is the mean of the random process? We got as what? 5 by 256. Like that, you can calculate the mean of the response of the system. And one more example, you will see on the mean square value. The question is what? A white noise with Rn of t, nothing but it is a autocorrelation function, is equals to what? 0.1 into del of t is applied to a network. So, is applied to a network. So, what is the input? Here, the input is what? Rn of t, nothing but what? 0.1 into lambda t. That is, in place of x of t, now I am having what? 0.1 into lambda t. Then, is applied to the, so this is a white noise is applied. So, not here, a white noise is applied. So, in place of x of t, here, we are having the noise n of t. So, what type of noise it is? White noise. And what is autocorrelation function of the white noise? Nothing but 0.1 into lambda t. So, n naught into lambda t. So, del of t. So, in place of n naught, I got a constant value 0.1. So, to a network, a white noise is applied. So in place of x of t, now I have here n of t. Then, and what is the impulse response to the system? It will be given as t into e power minus 2t u of t. Then we are getting the response to the system. So what is called is nothing but what? The network's output. And what you have to calculate? You have to calculate the network's output noise power. So that now what is the network output is y of t. Then what is network output power? Nothing but what? Y square of t only. So this is other way. Instead of asking the mean square value of the response of the network, they have asked the network's output noise power. The output's noise power nothing but what? P of y square of t only. So this is nothing but what? The output noise power only. So nothing but e of y square of t. What is e of y square of t? So already have done the formula for mean square value of the response system. Nothing but what? Integration minus infinity r excess of lambda 1 minus lambda 2 into h of lambda 1 into h of lambda 2 d lambda 1 d lambda 2. This is a mean square value of the response system. This already have calculated. So now in place of x of t, now we got the noise because to the system they applied as a white noise. So in place of x of t, here I have to write down n of t. Then what can I write down here? Integration minus infinity. So r n of lambda 1 minus lambda. This is the autocorrelation function. So into what? The impulse response h of lambda 1, h of lambda 2, d lambda 1, d lambda 2. Now, what is Rn of t? They have given 0.1 into del of t. So, they have given the autocorrelation function of the white noise power is what? 0.1 into del of t. In the formula, what you have to apply? Rn of lambda 1 minus lambda 2. So, therefore, what is Rn of lambda 1 minus lambda 2? Nothing but in place of t, I am having lambda 1 minus lambda 2. Now we substitute in the equation. Then what is output noise power? E of y square of t is equals to integration minus infinity. Here Rn of lambda 1 minus, what is Rn of lambda 1 minus lambda 2? Nothing but 0.1 of del of lambda 1 minus lambda 2 into what you have here? H of lambda 1, h of lambda 2, d lambda 1, d lambda 2. So what do you call this as del of lambda 1 minus lambda 2? It is called as what? Unit impulse function. How do you define unit impulse function? What is del of lambda is equals to 1 when lambda equals to 0 and 0 when lambda is not equals to 0. This is the definition of the unit impulse function. What do you call this as what? Unit impulse function. And similarly, what is del of lambda 1 minus lambda 2? This is only defined at the origin only, when it is 0. So when they get this is 0 when lambda 1 minus lambda 2 is equals to 0. So this is 1 when lambda 1 minus lambda 2 equals to 0. That implies what is lambda 1 equals to lambda 2 and 0 otherwise. Otherwise nothing but what? When lambda 1 is not equals to lambda 2, it is 0. Therefore, what is in the unit impulse function del of lambda 1 minus lambda 2? So, it's nothing but what? 1 when lambda 1 equals to lambda 2. Therefore, replace lambda 1 by lambda 2. Then what can happen here? Integration minus infinity. So, here what is lambda 1 is nothing but lambda 2 only. So, 0.1. So, 0.1 into what is del of lambda 1 minus lambda 2 value is 1 when lambda 1 is equals to lambda 2. So, into d lambda 2. In place of lambda 1 I replace by lambda 2. So, d lambda 2 that equals to 0.1. You can bring it outside. So, integration minus infinity h of lambda 2 square d lambda 2. Because I have given lambda 1 equals to lambda 2, you can replace this lambda 1 by lambda 2 only. Okay. Then 0.1 into, so what can you obtain? H of lambda 2. So what they are given the impulse response in the given problem? H of t equals to t into e power minus 2t u of t. Then, so given what is h of t is equals to t square t into e power minus 2t u of t. So t into e power minus 2t u of t. Then what is h of lambda 2? Lambda 2 into e power minus 2 lambda 2 u of lambda 2. Rs can replace in place of lambda 2 can replace by lambda 1 also. Then what is u of lambda 2? How it is defined? This is 1 when lambda 2 is greater than or equal to 0 and 0 when lambda 2 is less than 0. Therefore, I can split minus infinity as minus infinity to 0 and 0 to infinity. When lambda 2 is minus infinity to 0, what is the value here? 0. When lambda 2 is 0 to infinity, what is the value of u of lambda 2 value is 1. Therefore, so minus infinity, what is h of lambda 2? So lambda 2 into e power minus 2 lambda 2 u of lambda 2 square into d lambda 2. So that equals to 0.1. So integration at what is u of lambda 2? It is existing only when 0 to infinity. So 0 to infinity lambda 2 square into e power minus 2 lambda 2 whole square. Nothing but what? E power minus 4 lambda 2 square into what? D lambda 2. Now you apply the UV formula. Okay, now you apply the UV formula, then what can you obtain? 0.1. So into integration of UV is nothing but U into integration of V. So what is U? So lambda 2 square into integration of V. Now what is integration of e power minus 4 lambda 2 square is e power minus 4 lambda 2 square by, so e power minus 4 lambda 2 square by minus 8 into lambda 2. So minus 8 into lambda 2 minus integration of u dash. What is u dash? So lambda 2 square differentiation is what? With respect to lambda 2 is 2 lambda 2 into integration of v. What is integration of v? E power minus 4 lambda 2 square by minus 8 lambda 2 into what you have d lambda 2. The limits of lambda 2 are from 0 to infinity. Then here lambda 2, here lambda will get cancelled. Then what can you obtain here? If you substitute the upper limit, and then infinity into e power minus infinity is 0. If you substitute the lower limit, 0 into something, it is 0. Therefore, the first term will get cancelled. So 0.1 into here lambda 2 is get cancelled. And we can write this as what? 1 by 4 integration of e power minus 4 lambda 2 square into d lambda 2, and the limits are from 0 to infinity. Then we can write it as, so this is e power minus 2 lambda 2 whole square. Nothing but what? E power minus 4 lambda 2. So here this is nothing but e power minus 4 lambda 2. And here this is e power minus 4 lambda 2. And here also e power minus 4 lambda 2. Then we can write as, this is lambda. This is nothing but what? Lambda 2. So here e power minus 4 lambda 2 square. Then what can you obtain here? So if you substitute the upper and lower limits, the first integration is becoming what? 0. So infinity square into e power minus infinity is 0. If you substitute the lower limit, so 0 into something you are getting 0. The first term is get vanishing. Then what again here? So here 2 and 8. Nothing but 2 ones are here 4. So 1 by 4 integration of lambda 2 into e power minus 4 lambda 2 d lambda 2, and the limits are from 0 to infinity. That equals to what? 0.1 by 4. So 0.1 by 4. So integration of uv again is u into integration of v is e power minus 4 lambda 2 by minus 4. minus integration of u dash. What is the differentiation of lambda 2 with respect to lambda 2 is 1. So 1 into integration of v is e power minus 4 lambda 2 by minus 4, and the limits are from 0 to infinity. That equals to 0.1 by 4. If you substitute the upper limit, infinity into e power minus infinity is 0. If you substitute the lower limit, 0 into something, you are getting 0. Therefore, the first term will get vanished here. So here minus and minus will get plus. So 1 by 4, and integration of e power minus 4 lambda 2 is e power minus 4 lambda 2 by minus 4, and the limits are 0 to infinity. So you substitute the upper and lower limits, then what can you obtain here? You can write as what? 0.1 by 4. So 0.1 by 4 nothing but what? 1 by 10. So 1 by 10 into 4 is 40. So into 1 by 4 into, if you substitute the upper limit, e power minus infinity is 0. If you substitute the lower limit, e power minus 0 nothing but what? 1 by minus 4. So minus of minus 1 by 4 is 1 by 4. That equals to, so 4 into 4 into 4. So it is nothing but 640. So 1 by 640 is the answer. So like that you can calculate the mean value and mean square value of the response of the system. So in today's lecture we have seen the mean value of the response of the system, and then you have seen how to calculate the mean square value of the system response. That is also called as what? The power also. The power of the system. That is nothing but E of y of t and E of y square of t. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.